Take the floor, sir.
Thank you, Frank. And just want to say I'm thrilled that so many people are excited about Rails engines. So I'm certainly going to spend some time talking about them today. All right, let me just move some windows and present. I'm going to present this screen. All right, how's that?
Looks great to me.
Okay. Yeah, just a quick note. While I'm presenting full screen, I'm not able to see y'all's faces or the chat. So if something's off, please feel free to speak up. All right, so I'll introduce myself. I am Dmitry. I work as application architect at Calendly, and I get to work on all kinds of fun things. Uh, I primarily focus on integrations and API side in Calendly, but also, and the topic kind of gives it away, I, like many others at Calendly, are working on slowly decomposing our monolith into something that we hope is going to be more manageable for us. So here's a quick agenda. I'm going to talk about the kinds of problems we're actually facing and are looking to solve, and then transition into a bit more of the how, and then also reflect on where we've come so far and where we're headed from where we are now. So, and this is a common question that people ask: why break apart the monolith? What's wrong with that? So for the longest time, Calendly has been a majestic, as DHH puts it, Ruby on Rails monolith, and it served us well. I love DHH's article. He makes a lot of great points, and we are very practical people at Calendly. We try very hard to avoid finding problems to solve just because they tickle us intellectually. We believe that's the best work is no work, and we're all about not reinventing the bicycle. So the monolith has served us very well for years. We became who we are now, a successful, established company with lots of users and very considerable revenue. But we have started running into challenges, and we've really surfaced the topic of we should do something about this, not in an incremental way, but more in the current approach doesn't work, maybe 18 months ago or so. So here are the challenges that we started facing. The code base has obviously grown more. We now have, I think, close to 100 engineers contributing to the code base. And that doesn't scale well when there's a lack of component boundaries, lack of modularity in the code. And Rails is certainly not conducive to that, at least with the tools that it gives you out of the box. And then there's undesired coupling where you touch one thing and then there are all these hidden dependencies and hidden implications of your change. Of course, we have solid automated test suite that often catches the issues, but doesn't make it less pleasant sometimes to untangle these. The other thing that's kind of hand in hand with that is the app keeps growing, so it's becoming increasingly difficult to the point of being impossible for a single person to deeply understand the entire app in order to be effective at it, in order, again, to understand the implication of a given change on the whole system. And for engineers joining later in the company, that's actually even more challenging. They don't have that benefit of kind of digesting all these changes as they've been happening. On-call is an interesting perspective. What we've seen is monitoring alerts and errors, whatever you usually set up for your monitoring and on-call system, has also become more difficult because think of it, like many companies, we do an on-call rotation where people respond to all kinds of alerts. But because these alerts are channeled through a single stream, but they are originating from different parts of the system, it's becoming increasingly difficult for a given engineer or a pair of engineers who, say, are on call this given week to investigate them because they may not be familiar with that distant area of the code that they have never touched. And related to on-call is sometimes we do have incidents. We usually don't entirely go down, but part of the system becomes unhealthy, and troubleshooting those and finding a root cause is also become increasingly difficult for the same reason, because there are just certain, it's a large application, a lot going on with it. Obviously, it uses a lot of memory, a lot of processes going on. It's hard to pinpoint what exactly went wrong. And sometimes we end up just saying, okay, well, there's a perfect storm. There's a spike in usage. We queued extra jobs. Our workers have been crunching more, making more API calls. So it feels like you look at the graphs and just everything just explodes when some anomaly happens. And it's hard to pinpoint what was really the root cause, what was the culprit. Then, unsurprisingly, the bigger your app is, the longer it takes to build it, to run all the tests, to deploy it. And I'd like to break it down into, there's basically two major parts of the build process. It's building an image, we run containers in production, and then running the tests. Another one is monolithic scaling and single points of failure. Of course, we have multiple instances of the app running for high availability, but still, with increasing complexity of each instance of the app, there's just a higher chance that something will take it down. Some code that is seemingly harmless might bring the whole process down because it's one process. And scaling these processes, there's only so much you can vertically scale them, and we have been running into some platform limits in that area as well. And lastly, the decisions such as we have to upgrade Rails or Postgres or upgrade something on the front end, as you can imagine, are also more complicated and harder to justify and more impactful for the entire organization when you have a large app with tens of thousands of lines of code and 100 people contributing to it. And it's kind of hard. Of course, we find ways to do it safely, to sometimes update pieces of our app independently, incrementally, but it's hard because it's still a monolith, and there's really no, coming back to the first point, no clear boundaries between different components that you otherwise might be able to upgrade or refactor independently. And tech debt is basically saying the same thing, but from the perspective of cleaning up tech debt. We went through a few of these major efforts, like originally all our front-end code was in CoffeeScript, and now we're mostly CoffeeScript free, but still have a few places here and there that are lingering. So, of course, the knee-jerk reaction here, well, we got to split up the monolith. But how exactly are we going to do it? Well, any engineer who's been around for the past 5 years will probably say, yeah, we got to do microservices. It's clear we have all these problems, and it's more than just about slow build times or something else individually. We got to split this up into services. And that makes sense, but that's kind of the direction that we're going. But it's still a very big leap from this large monolithic application with lots of undesired loose coupling, this big ball of mud, to microservices. How do you go from this point A to point B? And we determined that a practical stepping stone on that journey would be to start with modularizing the monolith, which means for the time being, we're not necessarily going to worry about physically extracting pieces of code and putting them on different servers and calling them microservices and dealing with all the infrastructure and the complexity of the distributed system that you have to deal with. Instead, we're gonna mainly tackle in the beginning this lack of component boundaries and undesired coupling. And then the thinking is it should make it easier for us to proceed from that to distributed services. So that's the general direction we've been pursuing. And I'll talk a little bit more about the vision here. So this is kind of like how we think about it. So instead of a majestic monolith, we want to have a majestic modular monolith. And this is very abstract at this point, but hopefully easy to understand. We want our application to be mounting these modules, and these modules can in turn depend on each other. It still runs as one Ruby on Rails app, as a monolith. But the thinking here is that these modules would be encapsulating pieces of our business domain. They would hide their internals, which in a classic Rails app, you don't really enforce private versus public things. If you really want to, you can kind of access any part of the code from any part of the code. The other thing that we'll be able to do here, if we had such setup, is we would be able to get smarter about our builds. For instance, imagine if this little module here was changed in a pull request. Well, if we can trace these dependencies and we can trust them, this means that we would only need to run tests for this module, and then the module that depends on it, and then this root application that depends on it. We wouldn't have to retest everything else over here. Of course, if you're changing something like this guy at the bottom, you would need to retest more things. But the bottom line is, the more granular these modules are, the more efficiency we can get in our CI pipeline. And then, yeah, eventually some of these services can become standalone apps or services. That's the end goal. And as we continued looking into how we might pull this off, we started looking at our application from the perspective of two major planes. There are front-end concerns in the application, and by I mean front-end here in the loose sense, not just JavaScript, not just the UI, but front-end meaning there are controllers that handle requests and either return pages or return JSON responses. And then there are these more back-end concerns, your models, the services that implement business logic, that use the models, things like that. And so we've kind of been proceeding with this mental model of having front-end concerns and back-end concerns, and then trying to modularize them independently. Some of the rules that we established, and this is really a reinterpretation of classic modular programming principles, or the solid principles. And I'm going to borrow this awesome visualization. I think it's one of the best visualization of the terms high cohesion and loose coupling that I've seen. I'm happily going to credit Shopify for this. So these, and they call them packages in their own system. But I think it's a good illustration showing that in each module, it has things that are related that change together. But each module has a public API, and this is the only way that other modules are allowed to talk to this module. This is what we want to achieve. So now let's get to the more interesting things. What did we have to do to achieve that? How did we start? And essentially, our modularization framework are based on three main pillars: bundler, maybe that's this is a surprise to somebody, Rails engines, and Zeitwerk. So let's get the easy part of the way. Bundler, as we know, we all use gems. Bundler is the package manager for Ruby projects. So it's logical to attempt to use Bundler as a dependency manager to manage dependencies between these things, because that's exactly what the tool implements. Now, as I said, we're not looking to, in the beginning of the journey, we were not looking to immediately extract pieces of functionality into separate repos and launch them as services. We're still in a single repository, but we want to modularize our code. Now, you know that traditionally the way you use bundler is you declare dependencies to gems that usually come from Ruby gems, sometimes from private Git repos. But bundler actually allows you to declare what you can call local gems. So in the gem file, you can say that I want to load this gem from a local path. And this path can be relative to your project root. And this is exactly what we started utilizing to create those local modules that bundler would still know how to build, and bundler would know how to track the dependency tree for the project. So this works. There are some caveats and some edge cases. We did some monkey patching just to improve our quality of life, but in a nutshell, it does work, and I will show it in a demo in a minute. So Rails engines is another awesome thing that I discovered when we started this project. It kind of blew my mind that there is a kind of modularity mechanism in Rails. I also discovered that there are a number of existing open source projects that are implemented as Rails engines. So what Rails engines are, you can think of them as embeddable Rails apps that provide functionality to their host apps. So it's like a app, micro app, but it's not meant to be run on its own. It's meant to be mounted into a host Rails application. Now, the Rails engine has the same Rails app structure, same class autoloading. An engine can have controllers and models and concerns and all your standard Rails stuff. You can have generators working in the Rails engine. And a Rails application is actually, it inherits from a Rails engine. So it's a more specific variant of a Rails engine. Here's an interesting thing. We actually use all three of these projects. We use ActiveAdmin, Devise, and Doorkeeper. And if you look at the source code, they are actually implemented as Rails engines. And yeah, a Rails engine is a gem, so it has its own gem file and it can declare its own dependencies. But obviously, not every gem is necessarily a Rails engine. This below is just a link to official Rails documentation. It actually does a good job introducing you to the concept. I highly recommend reading it. But are you guys ready for a Rails engine demo?
That answer is yes.
Okay, so I generated a new empty Rails application. I have it running over here. No, not over here, over here. Yeah, so I have Rails 6.0. And so far, it doesn't do anything. That's just, I generated a Rails app and committed it.
I think the first time I ever saw Rails engines, by the way, of course, the ActiveAdmin, and then Spree used it extensively, if I recall. Which, anyway.
So. Yeah, and it's a neat concept. This means you can have essentially a whole application, but you can, in the case of ActiveAdmin, the brilliant thing about it is it's an application. It gives you an admin interface, CRUD interface around any model that you pointed to. So you can have and we use it as an internal support tool, where you can look up users and other things around what happens in Calendly. So here's how you would generate an engine. So I'm generating an engine inside a Rails application. Is the font size big enough?
Yes.
Good.
Yeah.
Okay. Yep. So, and again, just by looking at the output here, it's very similar to what you would see if you generated a Rails app. So it made some dummy controllers and models and assets and its own gem file. So let's look a little bit closer into what's inside. So I apologize. I can zoom in the text, but not the sidebar. Should probably switch to VS Code at some point. So if you haven't done gem development, I'll quickly mention that. So what we generated is a gem. It has a gem file, but it has a gem spec. And if you're not familiar with the two, if you haven't developed gems, basically the semantics are a little bit different from gem file in your root application. In a gem file declares dependencies that you only need for developing this gem. So they give you an example. You might include debug or a testing framework. Now, it also includes gem specs, so you don't have to repeat the same dependencies twice. But this is basically what you would add here are your development dependencies. And then what goes in the gem spec are the dependencies that this gem will pull with it when it's included in the project. And another thing that this Rails generator did is if we open the gem file of our root application, it added this line over here. So this is utilizing bundler's path gem dependency. Now it's telling us to load this gem from engine's foo directory. App has pretty much the exact same stuff you would have if you generated a new Rails app. Right now, it's just blank controllers, and yeah, there's not a job. There's a standard layout over here. Another interesting thing about the engine that you would not be familiar if you don't already know engines are, if we go into test directory, there's this dummy subdirectory. And what this is a dummy app. Now, because a Rails engine is not a fully fledged Rails application, Rails generates this special dummy app for you. It's essentially a shell application that is only ever initialized when you run tests for your engine, or if you open Rails console in your engine. So it's not used at all when your engine gem mounts into the main application. It's only used for testing. You can customize this testing environment, so you can maybe change some Rails settings, but just be aware that you are only doing this for the test environment. If you need some configuration that your engine needs to carry with it when it's mounted into the host, you don't put this in the dummy app. You put this, in say in, well, right now in config we only have routes, but you would make a config file here and load it in your app, do something like this. Let's see. Yeah, so this is just a high-level visualization of how our current project currently looks like. So we added our foo gem. This foo engine is almost like a Rails app. Everything here is loaded, well, except spec, is loaded when the main app runs with this engine mounted, and then the dummy app is only used for tests. Any questions so far? All right. Yep, go ahead, Nico.
Oh, I was just going to give you affirmation that no, I had no questions. Thank you, though.
Okay. Yeah, so we just generated that engine so far, but it's not doing anything. And while it's initialized in our main app, we're not using it in any way. So let's do something here. I will open a new tab, and I will see
Dmitry, I actually do have a question.
Yeah, go ahead.
Is it that gem file that came with it? Is it possible to extract a plugin or an engine that just uses the project's dependencies. I don't know if you said that or if it was clear that the gem file that is created in this, so like it could be mounted as an external dependency. Is it possible to extract an engine just as like it's still in the mono repo and you design it so it has boundaries, but it still uses the root project's gem file dependencies? So you don't have to like define all new ones.
No.
Okay.
So this is getting into what you do when you have multiple packages, and the answer is really almost agnostic of a framework or language. Like you would have the same problem if you had several JavaScript projects and each has a package JSON. What do you do when package A uses package B, but they need the same dependency? Well, you create package C that both depend on, or that B depends on C, and A transitively gets all these dependencies. So that's what you do, and that's what we. A lot of the first steps of our modularization were about that.
Okay.
Yeah. Thank you for the question. Yeah, and obviously, so it does say that what in the generated gem spec, it does include a Rails dependency, and you have to make sure that it's the same version of Rails than that your root project uses.
Cool. Thank you.
Something probably will not work well. Yeah. So what I was going to do is I was going to add a controller to our foo engine, and then mount it into the main app. So we're inside our foo engine, and it's basically like a Rails app. We can see that there's a bin directory with the Rails. We could open the Rails console here, and it would only be scoped to this engine. It would know nothing about the root app that we would later mount it into. But let's Rails generate. If I remember the syntax, controller, home, and then the action is index. I think this is the syntax. Maybe that's not the syntax. Oh, that's right. That's kind of an annoying thing. So it generates this engine for you, but it's very adamant about you going and opening your gem spec and fixing all the to-dos and fix me's. And I'm also pretty sure that it validates that the home page of your gem is a valid URL. I thought that was funny. Yeah, like it would actually not even run things for you unless you do this and remove the to-dos. Okay, let's try again. Okay, yeah, I think we got it right. So it generated a home controller. Now let's go to the routes file of our engine, because we're working in an engine so far. foo/routes. And actually, since we're going to be mounting this in the main app, let's just also say that the root route should also route to home -index. So now let's mount our engine into the routes of the main application, and we have full control over how we do this. Rails didn't do this for us; it only added the gem dependency. So if we open the root routes file, it's empty right now. And I'll actually open the documentation. Rails engines, getting started with Rails engines. And for that, mount command. There we go. So instead of larg engine, we have foo engine. And So we can mount it at any path we want. And this is, if you use active admin, this is how you would mount your active admin to, something like /admin. Let's mount it at /foo. So now, if we did everything right, if we go to localhost /foo, oh, interesting. Initialized constant. Oh, do I probably need to restart the app when I change routes, right? Okay, we got further along. Assets not precompiled. I ran into this when I was testing this, and I'm not sure why assets compilation is not automatically handled in this case, but let's not worry about that asset. We don't really need it anyway. I will just remove the style tag. Okay. So yeah, now this page is coming from our engine. So hopefully you can already see how we can utilize this mechanism to split this monolithic app into modules that are maybe in charge of individual sections of your app. And then these modules, they may also contain the relevant models and services and everything related to certain parts of the of the business domain. What else? So there's the last part of the framework. So this already works, but because this is Rails, it created a foo namespace, and what I also did is the way we generated this engine. It's let's go to say home controller. It's going to wrap all the classes essentially that you generate into this foo module. You can generate an engine where this doesn't happen, but for this modularization use case where you are intending to mount it into the main application, it's definitely a good idea to wrap all the controllers and model into a namespace, because you don't want this home controller to clash with your root applications home controller and so on. The nice thing that it'll also do is, it doesn't do that here, but it will also automatically prefix, if you were to create new models and new tables inside this engine, the names of the tables generated for your new models will start with the name of your engine. So if I generated a new migration to create, I don't know, users table inside of foo, it will actually create a table foo_users. So it also helps with namespace and things on that level as well. One thing I didn't show is the entry point for, because this is a gem, so following the convention, the entry point for our gem is actually here in libfoo. And we see that it requires foo/engine. This is something that's different from a regular Rails app. And there's not a lot going on here. It just declares that it's a foo engine. This isolate namespace is what controls namespacing. It tells Rails that this engine has to be, and all its classes have to be in a namespace named after the engine. It also what tells the model and table and the migration generator to namespace things under this engine. But it doesn't actually isolate things in a sense of making some classes private. So if I were to, let me just illustrate that. If I were to open the Rails console, this is the root application. Here's our foo engine. But we can also access foo home controller directly. We don't have any models yet, but ideally, and according to the modularization principles that I mentioned, we would like to have some enforced isolation so that a code that uses an engine cannot access its internals directly. That's the whole point. And you cannot really rely on convention here because at some point, someone will really need to access that model or that service, and you know how that ends. So this is where another helpful mechanism that's, well, a part of it is built into Rails and a part of it is in Zeitwerk comes in. And back to my presentation for a second. Yeah, we talked about the dummy app. So the third pillar is what enables true constant isolation. Actually, in the most primitive way, we have that built into Ruby. This is not even Rails. You can declare any class, any symbol as private to a module. And what that means is anything inside that module can still access it, but anything outside of foo would not be able to access our user class in this case. And let's actually start with that just to prove that it works. I'm going to just copy paste this and let's create a model. Oh yeah, and the other small oddity here, when you create a namespace engine with this isolate namespace, it does mean that your project structure for an engine becomes a little weird. And I know the file tree here is small. Let me actually open it in Finder. So the path for an engine is engines foo. But then when I go to app, every subdirectory inside controllers, helpers, jobs, there'll be this foo duplicated, which is a little ugly, but it follows the Rails convention for where you put things when they are in a nested namespace. So you can fight it, but it involves essentially fighting the way class autoloading is configured in Rails. And also, if you use generators, you would have to update or override all the built-in generators in Rails. And we decided that at the time it's not worth it, but you can do that. We decided to live with these extra subdirectories. So what I was going to do is I was going to create a new model, and we're not going to worry about creating an active record model just for the demo. Just going to create this user class, and I don't know, let's create a simple method. I'm going to save it to get highlighting the user RB. And let's define a method on that user. And it'll just return header. So we created this user inside module, and we declare that constant as private. Awesome. Let's make a class method. So now I'm gonna reopen the console in the root application. If I attempt to access through that user, it's gonna tell me that I can't do that because I'm referencing private constant. Yet I can definitely do that inside our foo namespace in our engine. So just to prove that, let's go to our home controller and let's call our user.hello. We're already inside module foo, so we don't have to write foo : user. In fact, if we were to do that, it'll not work just the way constant lookup works in Ruby. It's gonna prohibit that, thinking that we're not allowed to access a private constant. The only way to access a private constant from the same module is by relatively referencing it when your code accessing that private constant is wrapped inside of that module. So that's just a fun technicality that we learned about. And let's console log it just to make sure that it is being called successfully. Rails logger info, and let's put some masters in there. Cool, so this should work. Here are my logs, let me clear them. If I go to that page, I refresh it, page still works, nothing broke. And if we go to the logs, yeah, we see our A there. So this is the mechanism for constant isolation that you can use to enforce module private things. But of course, it's tedious to put this, remember to put this private constant in every class that you create inside of your module. It's also error prone. It's easy to forget, whereas in reality, the way you want access enforced here is you really want to make, if you think about it, you want to make everything in your module, and by module here, I don't mean a Ruby module, I mean a logical unit of a project, an engine in this case. You want to make everything private by default and explicitly say what has to be public, what can be accessed from the outside world. And here is where Zeitwerk helps us. If you're not familiar, Zeitwerk is a class loader. It's actually a standalone project. You can use it outside of Rails in a Ruby project that does not use Rails. Rails 6 uses Zeitwerk. Prior to Rails 6, they used their own class loader. Zeitwerk is better and more reliable. It addresses some of the weird class loading bugs that were not common, but were happening with Rails before. And Zeitwerk, it's actually customizable. You can customize a number of things. If you ever had to add a directory to a list of autoload paths, if you did it in Rails 6, you would have been configuring Zeitwerk. And another interesting thing that Zeitwerk has, it has this onload hook. What this onload hook does is it lets you run custom code every time a constant is being attempted to be loaded. So this is before Zeitwerk would go and try to look up a file on a Ruby file on the file system to load this class. No, actually, it may have been after the class is loaded, but before it's accessed. And you can set up this hook to work on any class, so that this will run on any class being loaded for the first time anywhere in your project. So you can see how what we can do here is, and this is what we did, we created our own wrapper on top of Zeitwerk so that we have this API for isolating all the constants that belong to a certain top level namespace, except for the constants that have to be public. So unfortunately, I don't have the full code that I can share with you today, but I'll see if we can create something shareable, because some of that code is specific to our project. But the gist of it is it's based on Zeitwerk's onload callback, and you just analyze, this can be not just a single level class name, it can be something, colon, something else. And you can split it by this class namespace separator and determine if a constant has to be marked as private or no. That's essentially how it works. So in our modularization framework, we essentially monkey patched Zeitwerk to create this isolate methods. And what that does is everything under foo will be private except for foo : API. Also, foo engine always is, I'm missing a colon here, but foo engine will always be public. So if all that our engine provides is a set of controllers or a set of routes, then you would need to export anything under public const. Our original code over here. Okay. So this would still work. You can still mount an engine. That's does not really count as accessing private internals of an engine. Foo.engine, foo.conn engine works. So in the way we utilize this, coming back to, well, actually, I'll tell you how we went about this. But any high level questions about engines or bundler or site work and private constants before we move on?
I was going to ask, is this truly private, or is this like most private things in Ruby that you can actually get around it very easily? Because Ruby is such an open language.
Yeah, you can, it's whatever private constant in Ruby does, which is it'll raise an error if you access things the usual way, but you can do const get and work around it. But nobody should really be doing const get. And you can write a linter to prohibit const get in certain places.
Do you know if send also then private constant doesn't allow that? I know that kind of overrides the private method in classes.
Yeah, I believe send also works around this. So,
and I suppose the silly way for me, the silly reason for me asking that, Dmitry, really has more to do with, you declare these things and it's kind of the normal way. And of course, you could not use this specific scoping and just scope based on how you access the methods and do your code reviews. But I understand what you're doing anyway.
Yeah, and I guess a third way of, if you really want to access something inside of a engine where everything is private, is in your root application, I can write module foo, and inside that block, I can access everything inside module foo.
Right.
But again, it's meant to be more of a enough of a trigger red flag for the developer to, okay, this is private. I should not be monkeying with this.
And I'm not sure you've touched on this yet. But how does this impact automated testing of these interfaces? Do you test only the public API or as a strategy, or do you also test some of the internal implementation details within the module? How does it impact it?
Yeah, so within the module, you would be testing most likely the internals of the module. Obviously, you may want to write a unit class for a model or a service, anything else. And to do that, you have to wrap your tests inside this module, and then it works from there. So you would be writing tests in a similar way, and employ whatever testing philosophy as far as what to test, how much to test, what to mock, what not to mock. Just wrap your tests in foo in your module. Does that answer your question? All right, so then we're on our final stretch. Just want to talk about the first steps we made towards this journey. We knew it would be a long multi-year journey, and we knew that we would also correct our perspective based on what we learned. So I want to talk about really what happened in the beginning and what we learned so far. So I mentioned how we started thinking about these modules and these concerns that we're modularizing into front-end and back-end concerns. We came up with better names for that because front-end and back-end can be confusing. We started calling these modules that essentially take traffic, modules that have controllers as apps. So it can be your API, it can be pages in your application, and then everything else is gems. And these gems can be more traditional stateless libraries, just utility functions, or we had a gem for settings that gives any module access to our application settings. That speaks to what Nico asked before. What if you need to share something across your modules, and application settings is reasonably something that, at least without further refactoring it, application setting is something that you would want to share across modules. So we extracted these settings into its own gem that provided an interface for reading the settings. And some of these, they're not all necessarily engines, but some of these gems would be more of a local module version of what could become a microservice in the future. So it's a module that gives you limited access to the main models and the business logic around, user management, event management, things like that. And this is essentially how our architecture, how we see our architecture evolving. Some of these backend things move to services. Apps might stay as modules within the application, or they might also migrate to standalone applications, especially their API things. So the very first thing that we did, according to this two-plane frame of mind, is we took our big ball of mod, our monolith, it's in original state, and we actually horizontally split it into these front end and back end pieces. So with that split, it was not that back end piece that split off, it was not a true module. We did not enforce any isolation there. We did not namespace hundreds of files, because that would be disastrous. But we did want to see how we physically moved a bunch of files to an engine, and this should be, the concerns here should be familiar to you. So these are what we called front end things, mainly controllers plus related things, things related to processing requests, and then services, models, and everything else related to that moved to a backend engine directory. So no access was limited, because it would be a huge amount of work to, you cannot just overnight create these clean API interfaces around existing concepts that do not have clean interfaces and clean separation of concerns. But we wanted to make this big move so that we can then start independently or in parallel modularizing these backend guys and these front-end controllers and related concepts. And modularizing front-end pieces has actually, understandably, it was easier. So that's one of the first things that we started doing. And of course, I'm omitting a lot of things. As we were doing that, we were improving our tooling, improving our automation, improving how we do builds, and so on. But this is roughly the state that Calendly's modular monolith is now. There's still a big backend engine that has a lot of stuff that has not been extracted, but we now have a framework of further attacking this. And yeah, ultimately, this is a copy of an earlier illustration. We want to arrive to something like this. So what's beyond, and what have we accomplished so far? These are the challenges with the monolith that I talked about earlier. We came to realization that simply going with the modular monolith approach, it has a lot of benefits, but it doesn't solve all of these problems. And here are the problems that it does solve. It obviously creates these logical component boundaries that makes further service extraction much, much easier, because untangling the spaghetti dependencies is enough of an exercise on its own. It helps us with more efficient tests, although there's still a lot to extract and split up to truly benefit from that. It would be easier to do migrations and tech debt cleanup on module level, because now we have these modules that we can reasonably tackle independently. But then there's all these other things and these are the theoretical maximums, right? I'm not saying we completely have solved this, but these are the theoretical maximums of a modular monolith approach. So it still runs as a monolithic app in production, so alerts are the same, interdependencies between components, between shared resources are the same. It scales as a single app. Upgrading Rails is still a pain because even though you have these modules, you cannot have these modules run on different versions of Rails, because in the end, it all comes into one host application that uses certain version of Rails and Postgres, one database, and so on. So it helps a little bit with deploy times, and it helps with developer productivity, because especially some teams that now are lucky enough to work on things that are more or less modularized so far, they can work more independently with less regard to the rest of the application. And with these things, what often happens is, you have this. We especially saw this with controllers. There's always a tendency to put a bunch of things in your application controller because some controller somewhere needed this. As you start splitting up your controllers, you actually clean this up a lot. And you realize, oh, half of the stuff in application controller is only needed for, say, booking, but it's not needed for all the pages for when the user who has a calendar account logs in and manages their stuff. So a lot of nice cleanup has been done. But obviously, these modules are not completely independent. Ultimately, they're still part of the same process running in production. So, I gave this point a yellow. So we are continuing to modularize our monolith, again, simply because it allows us to go through the exercise of untangling dependencies and creating logical boundaries without worrying about productionizing services and making services talk to each other. But we are moving in the direction of spinning up services, and we also try to take the opportunity to build new services for new features that are independent enough, because generally we wouldn't want to build the service that would depend back on a bunch of concepts inside the monolith, and we want to avoid some circular dependencies as well. But yeah, we know we're still far away, but hopefully this talk gave you some practical insights, and hopefully you at least now know more about how Rails engines work and how you might utilize them in your project, even if your application is smaller and you're not necessarily planning on moving to microservices anytime soon. And this is all I had. Any questions?
Awesome, thanks. I guess one question I have is, and then of course the whole floor can ask, but did anything catch you by surprise? Like you thought this was going to be easy and in a way, and it actually was quite hard or burned more time than you thought to get it to a working state?
In general, I'm pretty conservative. I always think that things are not as simple as I think, but there were certainly a lot of moments like I basically what I did in this presentation, I breezed through, I don't know, 8 months of us doing from the point we decide that we're gonna try to split up the monolith to where we are now. So roughly over here. This has been going on probably a year, not 8 months. It's November now. So it was hard in the beginning. It was hard and slow in the beginning. Moving files, like when we did that first split, even though we were not trying to rename things still broke. We still had to extract some minimal common dependencies. So it was just a lot of changing. There are places where we were loading YAML files, and you had to. It was assuming that you were loading them from Rails root, but then those files moved, so Rails root is no longer where that YAML file lives. Just a lot of, in a way, grunt work and dealing with Rails, trying to adapt this engine mechanism for modularization, which it's not exactly built for that. It's built for things like devise and active admin, but there was definitely some of the bending of those built-in mechanisms that Ruby and Rails have to our needs, and writing some tooling around it, and simply untangling a lot of dependencies that you didn't know you had. But the nice thing about this is, and we established that in the beginning, is because we let bundler trace the dependencies, and we let specs tell us if we did something right or something wrong. So we did have the specs to keep it real and keep us in check and make sure that we're not accidentally accessing something we're not supposed to be accessing, or that we're not introducing circular dependencies. Because if you create a situation where gem A depends on gem B, and then depends on gem C, and gem C depends back on gem A, the project simply will not run. Bundler will fail. And then that was a nice thing that we got.
I had a question. Yeah, thanks for sharing this info. I haven't played around with engines much, so I'm excited to do so more. The client that I'm at is looking into using Shopify's Packwork for modularization. And so I'm curious, you referenced it with that diagram. I'm curious if y'all looked into Packwork and why you decided not to go with it, if so.
Yeah, we looked at the Packwork, and we were inspired by some of the work that they did, and some like they are in a similar place. Given the problems that we were trying to solve over here, and the rules that we, excuse me, not here, the rules that we established, where was that slide? Challenges. The rules that we established here, we wanted to hard enforce constant isolation at the code level, whereas Packwork is more of a, you can say it's more of a linter.
That's a good point. That makes sense. That's different. I agree.
Yeah, so we decided to dig a little bit deeper, and we also, as I mentioned, we wanted to make our CI suite smarter. And I didn't walk over this, but we have another part of our modularization framework is a script that reads the dependency tree from bundler that bundler gives us, and it determines what changed in this diff, and it determines what to build and what to not build. And that's kind of the benefit that we earned by relying on bundler and making those dependencies harder.
Cool, thanks.
Any other questions?
I was just going to add to what you added, Dmitry, because I was looking into Packwork quite a lot, and there's a couple blogs and podcasts that they've gone out and spoken on what they've done. And one of the developers that was highly involved in creating Packwork and the modularization kind of went out there to say that Packwork, exactly as you said right now, Dmitry, has its place. When you've got a really tied together app and you need to find its rules in the first place, it's really great because it gives you those linting things that you want. And it was a great place for them to start. But in certain cases, they actually choose not to use it even within their own monolith when they're breaking it apart to. So it's kind of specific for its use case. And I, being a very newbie person, I couldn't tell you why.
Yeah, and in at least in one of the original articles about Packwork, they specifically say that they are not planning, or they were not planning at the time, to move to distributed services. So with us wanting to do that with that goal in mind, the tooling and the approach justifies that. Any other questions or comments? Well, thank you all very much. Just show a slide real quick. These are my social credentials. Feel free to follow me if you'd like. I will post a link to these slides there, but also on meetup.com for this meetup. Thank you all.
Awesome. Thank you, Dmitry.
Thank you very much.